Continuing with section 7.1, we're going to address the second half of this section, which involves simplifying rational expressions. So for those of you who are just joining us, I wanted to distinguish or to explain the difference between rational functions and simplifying rational expressions. So if you want to know what a rational function is, I'll refer you back to 7.1 subsection 1, the previous video. And if you're looking for how to simplify rational expressions, you've come to the right video. Okay? So again, we're going to go back to our definition of what a rational expression is. It is a term that can be expressed with a numerator and a denominator. And what we're going to note is that we want to get in order to simplify a rational expression, this is as simple as it gets. We have one term on the top and one term in the bottom. Working back though, realizing from chapter 1 we talked about the properties of numbers. And one of the properties we noted was that any number multiplied by 1 equals itself. Okay? And when we introduced this in chapter 1, or in high school or in elementary school, wherever you learn this property, you may have thought, well, this is kind of silly. I don't need to know, I mean, this is sort of obvious. When I have one of something, that's what I have. I have one apple or one orange, right? So why is this property valuable? This property is valuable when we note that we can write 1 as a rational expression. So would you agree also that 1 is equal to, let's use r. If I have something divided by something, the same thing, if I have r divided by r, I have 1, right? This is a very powerful principle because when combined with our multiplicative identity, we get a very powerful strategy for simplifying rational expressions. And that is this. We're going to start with a complex version of our numerator and a complex version of our denominator. This is a product term. So this is one term times another term. This is a third term times a fourth term. And we're going to use this very powerful principle to reduce our complex rational expression. I'm writing the r's first. I don't know why. This is the rule for multiplying fractions in reverse, right? You can split a fraction up. And then this is the application of the identity of anything divided by itself is 1. And we get back to the simplest version of our rational expression. This is the method that we're going to use from here on out when we're dealing with simplifying rational expressions. Our goal will be to identify the common factors that we can take out. Okay? So let's work on some examples. And let me just keep this rule up here so we have it, just so we have it. Obviously, when I work these examples, I will isolate the common factors, and then I'll just write the answer. I'll skip this step of multiplying by 1. All right, the first example is deceptively simple. Okay? Now, I am showing you that our strategy involves products, not differences, right? 4 minus x is a difference. It's a term of difference, not a term of products. This is also, x minus 4 is a term of difference, not a term of products, right? And if I had x, let's say for example, I had 4 plus x over x plus 4. This is a term of addition, okay? So remember, even though we don't write the multiplication symbol in our definition of how to simplify rational expressions, our method works only when we've isolated our expressions as products, as product terms. So here, I'm going to have to do a little bit of manipulation on this. because I can rewrite, let's start with rewriting the top with the x in front. I have to keep the negative sign in front of my x here. But I have to recall that since this is a positive number, I have to include the positive here. Okay? So now I have my letters in order, which is good. But can I rewrite this term with a factor pulled out? And the answer is yes. This is the same thing as pulling a -1 out of this whole quantity. So when I pull a -1 out here, all I'm left with is positive x. But when I pull a -1 out of positive 4, I'm left with -4. Ooh, that's good. Because what's my denominator? The quantity x minus 4. Now I have something like, where I have p times r over qr, where my p is -1, right? That's my first product term. My r is x minus 4. And my q, even though we don't write it, it's +1, right? Because I could just multiply 1 times this whole thing and get the same thing. And then my other r is down here. So even though it looked like we couldn't do anything because it was a difference term, we had to rewrite, massage our numerator, and find something that we could pull out so that we could reveal a common term. And now that we do, I said I would go ahead and write it as an expression of r over r, isolated by itself. And let's see, since these two terms are the same, they will cancel, or I should say they reduce to 1. And we're just left with -1 over 1, which is just -1. Okay? This, I wanted to illustrate this example, even though it's an easy example or somewhat easy example. I wanted to highlight this factor, sign changes, and being able to pull negatives out. This is a very fundamental skill that you'll carry on in higher math classes. So find problems like this in your textbook where you note that you have just a reversal of terms, and get used to the idea of pulling out a negative. Because in order to, if you can get comfortable doing this, then solving problems in tests and quizzes will get a lot simpler. So second example is going to be a little bit more complex. Okay. Now note, if you're continuing from our previous video, you'll note that I have not written y equals f of x. So I have a rational expression. I don't have a rational function. So the objective is to simplify. And we note right away that this looks like a collection of addition of terms that we need to add together, both in the top and the bottom. And again, we have to find a way to convert our quantities of addition into our quantities of products. So what we'll do is we'll use a technique that we've been using for a long time, which is we're going to factor this. Okay? We're going to, because this is in general terms a quadratic. And we find ways to express them. I'm not gonna write the terms because it gets really messy. But we're going to write it as a product term, right? That's what we're looking for. And we can also kind of guess, since this is a math exercise, that one of our product terms is going to be x plus 2. That's what we want to. If we can find a way to rewrite this as a product of some term times some other term, where it's x plus 2, then we know we can get these things to cancel, and we've simplified it. So let's see. We're going to use our method for factoring polynomials. The method that I like to use is a little bit more cumbersome, but it shows all the steps that are involved. And when you have numbers in all of your terms that aren't 1, this method works every time. Okay? So what we're going to do is we're going to look at our first term and our last term, and we're going to say we need the product of 5x squared times 2, which is 10x squared. All right? But we need to break this up so that we can rewrite this as a collection of two terms. Right? So when I multiply x times x, I'll get x squared. And now I need to multiply 10 and some other number to get 10. Well, not just any factorization of 10 will work in this case, because I need the factors that when I add them together equal my middle term. And you can probably see when I add 10x plus x, I get 11x. So what I'm going to do is I'm going to take this information and I'm going to rewrite my middle term as the sum of the two terms I know I need to factor. And now I'm just going to drop down the 2 and drop down the 5. And now I have a situation which you may have isolated already, or you may have recognized already, is that now I can factor by grouping. I have two common terms here and two terms here. Oh, and look at that. I have x plus 2. That's what I'm after. So now I just need to simplify. Okay? So what I'm going to do is I'm going to pull a 5x out of each, because each term in this group shares 5x. And that leaves x plus 2. And now I'm going to pull out a positive 1 to demonstrate the rest of my factorization. Because now I know that both of these terms share an x plus 2. 5x times x plus 2 and 1 times x plus 2 both have a common factor of x plus 2, which means I can pull an x plus 2 out of both. And I finally get what I'm after, my product term, 5x plus 1. This is a little bit longer way of factoring, but it's surefire in that it works with coefficients that are greater than 1, and it doesn't rely on any sort of mental tricks. You see all the steps happening, and it forces you to use your rules of distribution and association and commutation. So what we can do now that we've factored x plus 5x squared plus 11x plus 2, we can rewrite this as the product of 5x plus 1 times x plus 2. And if you wanted to take the time to check your work, all you would have to do is distribute 5x into x, 5x into 2, x, or 1 into x, and 1 into 2. Combine like terms, and you will get back to 5x squared plus 11x plus 2. All right, so really long way of just getting to what we're after, which is that, you know, we've got our P and our R and our Q and our R, don't we? Our P in this case happens to be, well, not equals, it's defined by 5x plus 1 is our P, x plus 2 is our R in the denominator is the same, and our Q is just 1. Okay? And then we, just to demonstrate the rules of multiplication of fractions, we note that we can pull it out, right? We're in this stage of our example where we've got R over R, which we know equals 1, so we reduce to 1. And 5x over 1 is just going to be 5x plus 1. And we have simplified that expression. Okay? So this was an example of where you have a trinomial. You have 3 terms, right? 1, 2, 3, trinomial. And we know how to factor a trinomial when it's a quadratic. That means it's got a power of 2. We use our factoring methods, and we conveniently get a term that reduces with the denominator, and we can simplify. Final example will be a little bit more complicated, but that's okay. Our strategy hasn't changed. What we're doing is we're looking for a way to rewrite our top and bottom as products and to find a common term and then extract that common term. So our last example is a little bit more complex, but our method stays the same, where we're going to start with a numerator and denominator that we're going to have to rewrite as a product, and then get a common factor. and then rewrite it to where we can use our identity property, and we'll have simplified our rational expression. Okay? So the bottom you can isolate as, or you may recognize as in the form of the top in our previous example. So we're going to use the same strategy that we used to rewrite this, we're going to use this strategy to rewrite this trinomial as a product of two binomials. Okay? And we're going to use the same method we learned that I showed you in the previous example. So we're going to look for the factors of 4x squared times negative 9 this time, which is going to be negative 36x squared. And of course, x and x factor this way. But the factors of 36 that we need are the factors that when we add them together give us a positive 5. And those factors happen to be a negative 4 and positive 9, right? Because when I add 9 to negative 4, I get positive 5. So what I'm going to do is I'm going to take this result and just move it over here. So I'll rewrite my middle term as negative 4x plus 9x, drop down my 9 and my minus sign, and then drop down my 4x squared. And now I've complexified my denominator into something that I can now group. And that's the idea. So we're going to group here and here. And I note that I can pull a 4x out of both terms. And I get x minus 1. And I can pull out a 9 in my second group, and I get x minus 1, which is good. Now both terms share an x minus 1, so I can pull an x minus 1 out of both of those terms, and I'm left with the quantity 4x plus 9. So that's good. I got my denominator rewritten as a product. But what about my numerator? My numerator, some of you guys who are looking at this numerator recognize it for what it is right away. But one thing that we can do is we can rewrite our 1, because 1 is a pretty unique number. When I take negative 1 cubed, I get negative 1 times negative 1 times negative 1. Right? Negative times a negative gets me a positive. Positive times a negative gets me negative. So I get my negative 1. Aha! This is actually a difference of cubes. This is a cubed minus b cubed. So here our a is going to be x, but our b is actually positive 1. Okay? And we have a rule about how to simplify, or how to turn this difference of cubes into a product. And that rule is we can factor out an a plus b, and we get, we factor out an a minus b. And then we get a squared plus ab plus b squared. And then let me just check my rule to see if I'm right. The way that I do that is just by distributing back in. So, and this is the proof of why this identity is true. It's called a direct proof. So a times a squared is going to be a cubed. A times positive ab is going to be a squared b. A times b squared is going to be positive ab squared. And now I'm going to distribute my b through to the three terms. This is also called superfoiling, right? Where we learned how to distribute 2 by 2. Now I'm doing 2 by 3. So negative b times a squared is going to be minus a squared b. Negative b times ab is going to be negative a b squared. And minus b times positive b squared is going to be minus b cubed. Let's see. I have a positive a squared b and a negative a squared b, so those will cancel. Positive ab squared and a negative ab squared, those cancel. All I'm left with is a cubed minus b cubed. And you would agree that a cubed minus b cubed equals a cubed minus b cubed. So, proof. All right, so now that we've isolated, well, I should keep my rule up here. So I have my difference of cubes up here that I've identified. So now, conveniently, I can turn that into a product. Okay, and that's the product I'll use. So let's see. I'll factor out an x minus 1. And I'm left with an x squared. And AB is just going to be positive 1 times x, which is just x. And then b squared, 1 squared is just 1. And now I rewrite my denominator, and I can see clearly that I've done my job. I've isolated common terms. I have a product in the top, a product in the bottom, and conveniently a common term between top and bottom. So I'll just skip the step. This term factor reduces down to 1, and my simplified rational expression becomes x plus 1 over 4x plus 9. Now we could try to factor this even further if we wanted to, but the only reason that we would do this is so that we can write this as a product term. And we might be able to write this as a product, but the only reason for getting it into product terms is so we can recognize whether there's going to be a common factor. We can't pull a common factor out of here, so we're just left with 1 times 4 plus x, or 4x plus 9. That's the only way that we can rewrite this denominator. Well, if we were to try, we'll never end up getting a 4 and a 9. They're just not there. So there's no, so you'll just kind of have to know when to quit. And I'm going to follow my own advice and quit right now. So we'll see you in the next video.